Hey folks, how we doing? Let's see. The acoustics might be a little bit bad. I have a bunch of fans blowing right now, so hopefully you can hear what's happening. Okay, so 4.3, 126. So we know how to do all these word problems, and we were doing them with one variable back in chapter 2, but now we're going to do them using two variables. So conceptually, what you should find is that it's a little bit easier. So in 126, tickets to a Broadway show. So I like using the table. So we have adult tickets, kids tickets, total receipts for 1650 tickets. So 1650 total tickets. Cost. So the adult tickets are 35, the kids tickets, children, C, 15, 1650 total tickets, and then they made a total of 47150. So right now you should be saying, hey, this is exactly what we did before. Yes. So rather than thinking a lot about what goes here, right, like I think what we did was put like x and 1650 minus x. Why don't we just put an x, or maybe an a and a c, whatever, put an x and a y, and then so then when we multiply across, we get a 35x, multiply across, you get a 15y. Whoops, I meant to put these numbers here. 1650, doesn't matter. No, not really. Okay, so that way we have this relationship, x plus y is equal to 1,650, and this relationship right here, 35x plus 15y is equal to 47150. Now, do you want to do the elimination method? If so, you could put this under here. Or do you want to do the substitution method? Well, I'll just do the substitution method. So x is equal to 1650 minus y, because I subtracted y from both sides. And I'm going to plug that in right here. So 35, 1650 minus y plus 15y is equal to 47,150, and then distribute ... You should be able to solve that. 127 looks pretty straightforward. 129 looks straightforward. So these ticket ones are pretty straight. So once you solve for y, then you can plug it back in over here to get the x. So I feel like this section shouldn't be too bad. 133. 133 is your homework. Let's just set it up. Word problems are always difficult to just film without reading what's going on in advance, but I'm crazy like that. Okay, 133. So we have nickels and dimes in a coin purse. The total value of the coins in the purse is 0.95. The number of nickels is 2 less than 5 times the number of dimes. How many nickels, how many dimes are in the coin purse? Okay, so once again, you would set up your little thing. Okay, we have 133, we have nickels and dimes. The value, so those are worth 5 cents, those are worth 10 cents. At the end of the day, we have 95 cents. If you put a 5 and a 10 and a 95, it would still all work out. Okay, and then the number of nickels and dimes, the total value of the coins in the purse. So I guess we would just say we have N nickels and D dimes, 0.05 N, 0.10 D. Let's make it lowercase d. Does that help anything? Not really. Okay. I keep putting that below. Total. One of those days, folks. Okay, so we have one equation, And now it says, what does it say? The number of nickels is 2 less than 5 times the number of dimes. Okay, so you have nickels and you have dimes, and then it says the number of nickels is 2 less than 5 times the number of dimes. So 5 times the number of dimes, oh, we made it a D, didn't we? 2 less. Let's see, Sherry, the number of nickels is, so the number of nickels, N, is, equal sign, the number of nickels is, equal sign, 2 less, so minus 2 at the far side, 2 less than 5 times the number of dimes. So here's the relationship between nickels and dimes. So this is one formula, and here's our other formula. So you could write down 0.05 N plus 0.10 D equals 0.95. And, well, it looks like it's pretty much set up for substitution. So if N, there's N, so why don't I put 5D minus 2 right there? So 0.05, and then instead of N number of nickels, 5D minus 2 plus 0.10D equals 0.95. And then, dot, 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 you keep going, and you're going to solve for D, the number of dimes. And once you have the number of dimes, you can use this formula to solve for the number of nickels. Aha! Okay. Let's keep going. So this section, I think, is pretty straightforward. Let's just set up number 145. Setting it up. See, 145. So once again, this is probably a homework. I say every other odd, so I'm not sure if it's 145 or 147. Same thing, basically. So this one is where we're mixing solutions. So let's see, 145, 15 liters of a 25% saline solution. She only has 40% and 10% solution in her lab. How many liters of the 40 and how many liters of the 10 does she need to make the 25? Okay, so read them a few times. So if we're talking about saline solution, so if you want some stuff that is 25%, you got some 40% and some 10%, you mix them together and you get something between 25%. Okay, so we got some 40% stuff and some 10% stuff, and we're going to mix it together and get something in between, 25% stuff. So far, so good. And how much of each? That's what I need to figure out. All we know is that at the very end, we need 15 liters of this 25% solution. Okay. This is 0.40, 0.10, 0.25. So this is sort of the percent of solution, and this is the total saline. So maybe without putting labels, it might be easier. So let's just put an X here and a Y here. So normally we would, back in chapter 2, think about what goes here, but now we just don't even think. Just put an X and put a Y. Boom, done. Now over here, 0.40X, 0.10Y, and then what goes here? Remember how the table works. You multiply across. 15 times 0.25. Grab my calculator, because I can't do that in my head. 15 times 0.25, or could I have? 3.75. Probably not. 3.75. Okay, so how does the table work? We have this formula and that. So we have x plus y is equal to 15, and we have 0.40x plus 0.10y is equal to 3.75. You could do elimination method, but it seems like it's ready to go for substitution. Since there's just like an x and a y, what if I call this, bring the y over, subtract y from both sides? So if x is 15 minus y, you see I can just plug it in right there. So 0.40, and instead of x, what is x? It's 15 minus y plus 0.10y is equal to 3.75. And then you should be able to handle that. So I'm going to say dot, dot, dot. Go ahead, you solve for y. Once you have y, plug it back in here, you get x. And that'll tell you how much 40 and how much 10% saline solution. All right. Okay, let's try one of these interest problems. Kind of like the setting things up. So let's try, we'll set up 151. 151. 151, we got a big table. Okay. Carol invests $2,560 into 2 accounts. Into each account? Okay. Oh, no. Not into each, total. So $2,560, how much in each account? We don't know. Okay. One account paid 8% interest, the other paid 6%. She earned 7.25. Okay. So it's kind of like the problem we just did, but instead of percentage of saline, it's sort of interest rate. So let's see, 151. Tell me if this makes sense. There's an 8%. There's an account that earns 8%. There's another account that earns 6%. She's going to put some money into this account, some money into this account, but at the end of the day, it needs to be something between them. 7.25%. Okay. So 0.08, 0.06, 0.0725. How much money does she have total? 2,560. And then here's why this is easier than what we were doing before. How much in each account? I don't know. Let's just call it X and Y. Cool. So multiply across 0.08X, multiply across 0.06Y, multiply across. Calculator. 2,560. Whoops. Clear. 2,560 times 0.0725. Enter. 2,560.0725. 185.6. Okay. So how does the table work? We have this relationship, x plus y equals 2,560, and we have this relationship, 0.08x plus 0.06y equal to 185.6. And you could do elimination method, but like last time I was saying, if you just got an x or a y, it's pretty much ready to go for substitution. So subtract y from both sides. X is equal to 2,560 minus y. And now let's substitute that in for this x right here. So 0.08, and instead of x, let's put what x really is, 2,560 minus y, then plus the 0.06y, equal to 185.6, and I ran out of room, but hopefully you can see that. And then you can solve. So there's the equal sign right there, equals this. So notice what we did. We've two variables, we got it down to one variable which we can solve. Go ahead, solve for y. Once you have y, come back over here, plug in, get x. So ... You should be able to figure that out. So hopefully what you realized is, oh, we were doing these problems back in chapter, I think it was 2. Yeah, it's kind of a pain. I had to really think a lot about what went into each of these. But now that we know how to deal with two variables, it's real easy. Oh, what should go here? What should go here? Don't really care. I'll just put an x, put a y, boom, boom, boom. The table gives me all the relationships. I know how to solve two equations, two variables. Cake. Okay. Okay, so you should be able to handle 4.3.